All right, let's get right into it. The silicon hegemony. Sounds kind of dramatic, right? Well, that's because it is. We're about to unpack this incredible, high-stakes story of strategy, architecture, and pure economics that is, no joke, shaping our future.
I mean, you've seen the AI revolution firsthand, right? You've played around with ChatGPT, you've definitely heard all the buzz about Google's Gemini, you've seen the mind-blowing stuff they can do.
But here's the thing. Underneath all that flashy, incredible software, there's a hidden war going on, a brutal battle over the physical hardware, the actual silicon engines that make this whole revolution even possible. And that's where our story really kicks off.
So we're going to pull back the curtain on this hidden AI war. And while we're at it, we're going to completely debunk a super common myth, one that's just flat out wrong, about how all this tech actually works. Okay, so here's the myth. We're calling it the false dichotomy. You've probably heard this story before. Nvidia, they build the big, beefy, powerful chips for training these giant AI models. And then Google, they build the small, efficient chips just for running them, what we call inference. Well, let me tell you, as we're about to see, that whole idea is now totally, completely obsolete.
So to really get why that myth is dead and buried, we've got to go back, way back, to the very beginning, the origins of our two tech titans, and the completely different philosophies that basically set them on an unavoidable collision course.
And this really boils it all down, doesn't it? On one side, you've got Nvidia. Think of them as the ultimate arms dealer, a merchant silicon company. Their entire game is to sell powerful, flexible chips to literally everyone. But Google, they're the complete opposite. They're a fortress. They build what's called captive silicon. These are custom, hyper-efficient chips built for one customer and one customer only, Google.
So you got to ask, why build a fortress? Why go through all that trouble? Well, this quote right here, it explains everything. Back around 2013, Google was staring down an existential crisis. For real. Their top scientist, the legendary Jeff Dean, basically did the math and had this terrifying realization. The cost of running their AI models on regular hardware was just unsustainable. It would break the bank. They couldn't afford to buy chips from anyone else. They had no choice but to invent their way out of this mess.
And this is just a brilliant way to see how they pulled it off. You see, Nvidia's GPUs are super flexible, but they waste a ton of energy. Their processors are constantly running back and forth to memory to grab data. It's like a bunch of workers constantly running to the tool shed and back. It works, but it's not efficient. Google's TPU, on the other hand, uses this totally different design called a Systolic Array. Just think about this. Data flows directly from one little calculator to the next, almost like blood pulsing through the heart. It's just radically, unbelievably more energy efficient. So, okay, Google has the more efficient chip. Game over, right? They win. Nope, not even close. Because this next phase of the war, it wasn't about the silicon at all. It was about something much more important, the battle for the hearts and minds of developers.
I mean, think about it. You can build the most amazing hardware on the planet, but if no one knows how to actually use it, it's basically a very expensive paperweight. And that's the key. While Google was locked away building its secret fortress, Nvidia was out there arming the entire world. And in doing so, they built a software ecosystem, a moat, that would become almost impossible to defeat.
And here's how they did it. It was this genius, self-reinforcing cycle. First, researchers just fell in love with this easy-to-use framework called PyTorch. And guess what? Nvidia made absolutely sure that PyTorch ran lightning fast on their GPUs thanks to their special software, CUDA. Pretty soon, that Nvidia-PyTorch combo became the default. It's what all the universities started teaching, so you had an entire generation of brilliant AI talent graduating, and they only knew one way to build AI, the Nvidia way. That right there is the CUDA Moat. It's brilliant.
And this brings us to the great, almost painful irony of this whole story. In 2017, it was Google researchers working on their own secret TPUs who invented the transformer. You've heard of it. It's the fundamental architecture behind everything. ChatGPT, Gemini, all of it. But, and this is the crazy part, because the entire rest of the world was trapped inside Nvidia's CUDA Moat, it was other companies, like OpenAI, who ended up using Nvidia's hardware to cash in on Google's own brilliant invention. Ouch.
So for years, it really looked like Nvidia's software moat was just unbreachable. Game over. But Google had an ace up its sleeve, a secret weapon. See, they weren't just building a better chip, they were building an entirely new kind of supercomputer.
Now here is the absolutely crucial point to understand. When you get to the insane scale of a modern supercomputer, with tens of thousands of chips all wired together, things will break. It's not a maybe, it's not a risk, It's a statistical certainty, and a single one of those chips dying can bring a multi-million-dollar, weeks-long training job to a screeching halt. This was the massive problem Google's next big idea was designed to solve.
Okay, so Nvidia connects all its chips using this fast electrical network called InfiniBand. It works, but it's a power hog. Why? Because at every single switch, it has to convert light signals into electricity and then back into light. It's clunky. Google's approach? It's something else entirely. It's called Optical Circuit Switching, or OCS. And instead of converting signals, it uses an array of tiny, microscopic mirrors to physically steer pure beams of light between the chips. There's no conversion at all. It's a true photonic network. It's basically science fiction.
And this right here gives Google a genuine superpower. OCS isn't just a network cable, it's more like a photonic nervous system for the whole supercomputer. First off, it's insanely efficient. We're talking it cuts network power usage by over 90%. But the real magic, the most important part, is the fault tolerance. When a chip inevitably fails, the system can just reroute the light around the dead end in milliseconds. It creates a self-healing supercomputer. The multi-million-dollar training job, it just keeps on running like nothing ever happened.
So, this incredible infrastructure advantage, it set the stage for the climax of our whole story, what we're calling the Great Convergence. This is the moment where all the old rules of the game, and especially that false dichotomy we talked about at the beginning, were just completely and totally shattered.
So why did it all change? Well, generative AI basically rewrote the physics of the problem. See, for a modern AI to generate even a single word of text, it has to load its entire massive brain into memory, all at once. And suddenly, the insane amount of memory and power you need just to run the model, for inference, started to look almost identical to what you needed to train it in the first place. The two jobs completely converged. And just look at this. This is the head-to-head showdown. Google's latest TPU against Nvidia's latest GPU. The first thing you should notice, look at the memory. It's identical, 192 gigs. Google has totally closed the gap. The real difference now isn't in the specs, it's in the philosophy. Google is betting the farm on system-level efficiency and massive scale, thanks to that optical network. Meanwhile, Nvidia is still all about brute force, cramming as much raw power as possible onto a single piece of silicon.
And it's not just hardware. Google is fighting back on the software front too. They have this new framework called JAX, and it takes a completely different approach. Think of it this way. PyTorch is like a cook who follows a recipe one step at a time. JAX is like a master chef. It looks at the entire recipe at once and figures out how to combine steps and optimize the whole cooking process from start to finish. The result? It's dramatically more efficient on their specific hardware.
Which brings us right up to today. We're in a new Silicon Cold War. And the fight isn't just about who has the fastest chip anymore. That's old news. Now, it's a battle of pure economics. It's all about something called TCO, or total cost of ownership.
And if you want the ultimate proof, the ultimate validation that Google's strategy is actually working, here it is. When Apple, one of the biggest and most demanding companies on Earth, needed to train their foundational AI models, they didn't go to Nvidia. They went and rented time on Google's TPU supercomputers. And you know what the deciding factor was? It wasn't just raw speed. It was that self-healing reliability we were just talking about. They just needed a massive system that worked, period.
Because at the end of the day, it all comes down to the bottom line. First, Google completely avoids paying that massive 70+% markup, what people in the industry call the Nvidia tax, because they design their own chips. That's a huge CapEx, or capital expense advantage. Then, because their chips and their network are so hyper-efficient, their electricity bills are way lower. That's their OPEX, or operational expense advantage. You put it all together, and the math is just staggering. Google can deploy roughly 3 times the compute for the exact same investment.
So that leaves us with this one final massive question. The initial AI gold rush is over. You know, the period where everyone was just scrambling to buy shovels from Nvidia. We're now entering the industrial era of AI. An era where massive scale, reliability, and cost efficiency are what matter most. And so the big question is this. In this new era, will the most efficient system, the most economical system, ultimately win out over the system that's simply the most popular? The next few years are going to tell the whole story.